Unity framework. Hot chocolate, red well. Azure Cosmos, Dapper. Entity framework, Power Tools.
Technology suite.
Countdown commencing. T-minus 2 minutes.
Jeremy Lickness.
Shiro Dent.
Chris Lanson.
Arthur Vickers.
.NET data. T-minus 1 minute. Thirty seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff. We are go for .NET Data Community Stand-Up.
Hello, we're Go. We're here with another .NET Data Community Stand-Up. I'm back in the UK now, back in my normal place, so no more Greek sunshine or anything like that. Oh, thanks. Yes, I made that, so give me my award. Yes, so I'm here with Jeremy and Shai again. We don't have a guest this week, so we were talking about what we should do and decided to try and start doing a deep dive into the internals of EF Core. I'm a bit nervous because I haven't really prepared anything, so we're just going to go jump in there, look at the code, and I'm going to talk, and those guys are going to comment, and you're going to ask questions, and we'll see how it goes. But what could go wrong, right? So anyway, so before we do that, we'll do a quick state of the unicorn, and I'm not even prepared enough to have my screen shared, but here we go. Okay, so yeah, so I was going to remove the lightsabers because it's not the 4th of May anymore. But then an Obi-Wan's Kenobi series started this weekend, so we've got Obi-Wan and Darth Vader fighting there. So anyway, what's going on? So we haven't really done much in the last couple of weeks, so there's not much on here. But anyway, I'm going to go
Not true.
So aggregate functions. So Shai, yeah, you've been avoiding distributed transactions by working on aggregate functions, right? So you want to talk a little bit about that?
In 2 words, sure. So Smith actually did all the infrastructure work. Aggregate functions, everybody knows them. They're functions in SQL, which take a lot of rows and output a single thing like a scalar. The example is count. When you do select count star from something, you're using an aggregate function because you're taking all those rows and you're condensing them into a single value, which is the output of count, right? The thing is, of course, EF Core supports aggregate functions. You use them, I'm guessing, every day. You're using count and max and min and average and sum. These are basically the 5 built-in functions that we've always supported. There's no way an ORM can exist without supporting them. But the nice thing about EF7 is that we're bringing support for custom aggregates. So it turns out databases have additional aggregate functions, sometimes very specific to databases. One example is standard deviation. So you can, if you have a column of, of whatever values, you can ask the database to compute the standard deviation of all those values and just get that scalar back. And you can use that, by the way, also in group by. So you can group by department and then apply standard deviation to all the values for that department. It's really cool, and we're bringing that's going to be like a nice thing for EF7. We're going to be bringing support for a lot of funky, weird, new, cool aggregate functions that exist in various databases. Another good example, by the way, is string join. That's something people have been asking for. So you can basically, take the entire table, and you can take one of the columns and you can instruct the database to join that together with a delimiter, like with commas, and you just get a big string out of it. And that can be very useful in many situations.
And some spatial functions, right?
So there's like there's statistics functions like standard deviation and variance and various ways to do like that. I'll address analytical in a second. There's the string join. There's spatial ones, which there's about 4 of them, which are kind of standard, let's say. So we've implemented them. And on the Postgres side, there's a whole slew of them, which I've also worked on and brought together. For example, in Postgres, you can aggregate all the values into an array, because Postgres has the notion of an array. So you can kind of collapse an entire column into an array containing the values in that column, and then even further do array stuff on that thing, if that makes sense, or just load it back. Tons of amazing, weird stuff. But anyway, I'm taking up too much time. Window functions or analytical functions is not something we plan on supporting for EF7. So that's like another step further. Aggregate functions basically just, I'm not going to go over it too much. With window functions, you do partitions. So you partition your data. You can do something like a sliding window, where every time you take like 3 rows and compute, like you take like rows around the row you're interested in and compute like maybe a moving average. There's various things you can do there.
And there's an issue for that, right? So vote for that if there's something that you're interested in.
The problem there is mainly that we would need to invent some form of API in LINQ. The problem is how to express all that stuff in a LINQ query, and we've honestly not seen almost any demand for it from people. So maybe in the future. And whether these functions are called through EF functions or not is actually an open question. It's one of the important open questions. Right now, it seems that they are, but there's some tricky things which we have to solve. But in any case, it's going to come through for EF7. String join, by the way, is something that's built in. So as we always do it, because it's built in, we're going to translate that. We're not going to introduce something in EF functions because we already have a suitable thing on a normal .NET kind of API. Standard deviation, there's nothing like that in .NET built in. So we have no choice. We have to introduce a new thing. It will probably be on EF functions, but we have some design work to do on that.
Excuse me. Okay, so another thing that I've been working on is various lifecycle hooks or events, interceptors, and one of those is one of the big ones that people have been asking for is an object materialized, and the first kind of part of that is now merged just an hour ago actually. And that is allowing you to override the instantiation binding, which basically is what we build into the expression tree to call a constructor or a factory method to create your entity instances. So this is a very low-level hook that lets you change what we create. And if you think about it, one of the things that does that is when you use a proxy, because instead of wanting to create an instance of your entity type, you want to create an instance of the proxy type. So we kind of had a custom method for doing that in the past, and I updated lazy loading and change tracking proxies to use this new interception. And that resulted in greatly improved perf when building a model with proxies, because basically before we were creating all of the dynamic proxy types up front when you built the model, which is very slow. And now we just do it on demand. So when you do a query for that type, you get the proxy type created at that time. So when I say it's much faster, obviously, if you were to use all of the types immediately, then it would still be the same speed because we're still doing the same work. But generally speaking, if you've got a big model, that's not the way it works. So model building is much, much faster. essentially model building with proxies now has the same perf as model building without proxies. So that's something that a lot of people are looking for. And also because we don't have to create these in the model, the dynamic types, it means that proxies now work with the compiled model, because the compiled model was just going to ask the interceptor, all right, create me a binding for this, and it will create the dynamic type there. So now even if you've got a big model and you're using lazy loading proxies, you can compile that model and get even better perf on your model building. So that's a great example of some things all kind of falling together, which was really nice.
Isn't this also a building block
ahead.
for the object materialized event that we
it's
implemented?
one. It is, but I want to add some easier to use object materialized events that don't require that you mess with the expression trees and all that kind of stuff. So this is like the lowest level. I want to really just change the expression tree we're compiling. As opposed to, hey, just call me and let me do something on my object once it's created, which is it's on my list to do as well.
Lots of people have been asking for. Yeah.
We mentioned this last time, but TPC, table per concrete type, is now in there. We're going to do a community stand-up on that maybe next time. But yeah, that's in the daily builds, and so play around with that if you haven't yet. And then in system data, Shai's been working on this thing called DB data source.
Yeah, it's hard to explain in 2 seconds, but I'm gonna try anyway. So in general, when you're not using EF Core, you're just using something like Dapper or ADO.NET. You just new up a connection, right? You do new SQL connection or NPG SQL connection. There's something missing there. What's missing is the concept of a database in the API, which is a thing from which you can get the connections. So instead of newing up a connection, what this is it's an abstraction to represent a database, and you go to that. It's basically going to be a factory for connections. That's important because in various cases like DI, you want to register something like this in one place, and it's going to contain all your connection information, like the connection string, maybe SSL callbacks, various configuration you want to do. That's the place where you want it to happen, in that one single place. It also corresponds to a connection pool directly. So once you have that thing, you have a DB data source and you're getting connections out of it, it directly references a connection pool inside your driver. So there's some perf things happening there, and it's generally going to unlock a lot of goodness in some advanced scenarios, which I've been looking forward to. So it's this kind of, it's a good example, system data or ADO.NET. It's not something that evolves a lot. It's a very, venerable, I think is the word, like an old API in .NET. So we cannot evolve it very much, but we do try to improve it where we can without breaking anything, obviously. This is an example of something I'm happy I'm able to push through that will make, life better, both for providers and for especially for users, obviously. So hang on, and I'll, wait for it, and I'll post a blog post about this in the coming months.
Good stuff. Okay, so that being said, let's start talking about EF internals. So I should have prepared a slide for this, and I intended to, but then time got away from me. I was too busy searching for lightsaber clip art, to be honest. Anyway.
Prioritization. Arthur is my manager. He always talks about priorities, but sometimes he's not that good.
Well, do you think I think the lightsabers were higher priority? Anyway, no. So when you use Entity Framework, you can Entity Framework Core. If I see Entity Framework, I mean Core at this point. When you use Entity Framework, you use it. You can use it with dependency injection, or you can use it without dependency injection. So in an ASP.NET Core, for example, application, by default, you have a DI container, and you call add DB context on that, and then you resolve the DB context from it. And that DI container, we generally refer to as the application DI container, the application service provider, or the external service provider. But internally to Entity Framework, we also use those same DI abstractions to build Entity Framework itself. And so essentially, when you use Entity Framework, what you're using is a collection of services that implement various service contracts, and those services can be provided by the core implementation of EF, or they can be provided by a database provider. So for example, the SQL Server provider can say, oh, I actually want to implement this service slightly differently. And then plugins can also provide implementations or change the behavior of certain services. So
Even users.
or that's less common, but that is still possible. And that's kind of the key to the extensibility story, really, around EF. We try to expose common extensibility in ways that don't require you to work directly with the services, because as we're going to see, it can be a little bit complicated. But basically, the whole idea of in the old days, when I was working in Java and DI, and we had this early DI framework, we used to call this a service-oriented architecture, and I think that's a very overloaded term, but the idea is the same, right? The idea is that you have a bunch of services, and then you implement those, and they use a DI container to couple them together to create a running system. So that's what we have inside EF Core. And that's kind of the fundamental kind of architecture, an architecture block there. So today I'm kind of go wing it and look at the code. So let me share here, and we're going to go through how some of that stuff works. So share this screen, okay, and add it to the stream, and there we go. So
and zoom in the font.
Zoom in the font. It's already on the presentation mode, so it should be pretty big, but we need it bigger.
Oh, yeah.
There we go.
That better?
No, I was kidding. You haven't moved it yet.
I have.
Hold on, No, it looks good from here.
Yeah, it looks
okay.
good.
Okay. So, where to start is always a difficult question. And so what I've decided to start on is this class called the Entity Framework Services Builder. Now, we use the DI container, but one of the things that we found in the early implementations of EF Core was that managing these services, knowing what service were available, and particularly what scope they should be, and whether or not you would expect multiple instances of the services or just a single instance, single implementation, was quite hard to manage with just DI, with just the DI abstractions on its own. And so this is where the Entity Framework Services Builder is. And the first thing you see here is that we actually provide this is essentially a definition of all of the core services that every Entity Framework application has when it's using a DB context. So we have things here like the model customizer, model source, the iModel validator. This is one I'm going to come back to a lot because it demonstrates a lot of the things. So what we say here is that the iModel validator, and we're saying this is a singleton service. Now I'll get back to what that means in a second. And in the service characteristics class here, we also say whether or not it has multiple registrations. So most services, including the iModel validator, there's only one of them. So you can depend on a single model validator, and you will get one. So if a provider, for example, wants to change the model validator, it will change that single model validator. There's only ever one model validator in the system. If we go down, we'll see there's more services. Some of them are scoped. But some of these at the bottom here actually have multiple registrations true. And these are things like interceptors or things around plugins, so convention sets, that kind of thing. And the idea here is this is where the core of EF can add them, providers can add them, plugins can add them, and there may be multiple of these registered. So for interceptors, for example, you could register multiple interceptors in the service provider, and we would iterate through all of those and do whatever it is to all of those. So in a sense, you don't replace them in the same way, you just add to the list of ones that are registered. So we have here then this definition of what all of these services are. And this then allows us to add some methods down here, such as the try add core services. I'm going to get to it. Here we go. So this is the So this method is what essentially adds all of the default implementations of these things. And you'll see we don't use a triad singleton or a triad scoped. We don't pass that in here. We just say triad, and then in our infrastructure here, it will make sure that it adds it with the right scope in the right way. I think if we actually look at this, we can see it's fairly straightforward. There's an overload of that. And then we basically just say, okay, well, if it's multiple registrations, we'll add an enumerable for a service for that. So you'd resolve an IEnumerable of that type. So for example, to get interceptors, you don't really do this, but in concept, you get an IEnumerable of IInterceptor, and that gives you the list of all of those that are registered. Whereas for most services, for example, the iModel Validator, we would just add the iModel Validator type directly, and you resolve the iModel Validator. Shai.
I think it might be useful to go. Can we look at compare a scoped and a singleton service
Yes.
just to get an idea of
Yes.
what that means in this context?
Indeed. I was going to come to that.
Oh, sorry.
Yes. No, that's fine. That's fine, because that was my next thing to talk about anyway.
Cool. Perfect.
So yeah, so if we go back and let's see.
I'm guessing everybody is asking themselves, what does scoped even mean, right? At this
yes,
point.
Exactly.
Even.
So just to quickly a quick overview of what a DI scope is in general, and then we'll look at it in relation to the EF internal service provider. So in general, a DI scope is something that you create, which then allows you to resolve services for some period of time while that scope is active, and you get a new instance of that service for that scope. And then when you end the scope, usually by disposing the scope, essentially, all of those services go away, and the next time you create a new scope, you get new instances of those. Now, if you compare that to a singleton, a singleton service, you always get the same instance. It's in the design pattern sense, it's a singleton, so you always get the same instance of that service from the service provider, from the DI container, regardless of whether you're in a scope or not. So that's the difference between scoped and singleton. Now, there's also transient services, which we don't use very much in EF internals. And transients means, regardless of whether there's a scope, regardless of where you're getting the service from, you'll get a new instance every time. And so that's just to be for completeness. So now if we put this inside the context of the EF, in the EF's internal service provider, a scope corresponds to the lifetime of a DB context instance. So basically, when you create a new DB context, you get a new scope for that instance. And any services you resolve from that are only valid for that scoped DB context instance. Okay, so let's make that a little bit more concrete by looking at some of these things. I'm trying to click on my screen rather than on the actual code. That helps. So, for example, let's see, the iNavigation fixture. So the iNavigation fixture is something that does fix up between entities when you track them. So this is something that will say, okay, you've got a blog, it's associated with these posts. So I'm going to go to those posts and I'm going to put the reference back to the blog. I'm going to set that navigation back, and I'm going to set the foreign key value to the correct thing. So it makes sure that your graph is in sync. Now that is a scoped instance. That's a scope service. It works with it lives for the lifetime of the context, and then it goes away, and then for another context you get another one, and that allows it to maintain and manage state associated with the context instance, right? Another example, let's see, it's a good example down here of that. Let's see. I'm trying to find one which, like the state manager, I guess, is a good example. So state manager is the thing that's actually doing the tracking. It's the thing that is keeping track of which entities are being tracked by the context, whether they're in the unchanged, the added, deleted state, all of those things, right? And so when you track with a context instance, the state manager is the thing that actually keeps track of those things. So if you've got two context instances, you've got two state managers, and each of those is associated with a certain context instance because they have their own DI scope, and so they don't interfere with each other. Your instances are separate. Okay, so let's compare that now to these singleton services. So singleton services, the same instance is used regardless of how many DB context instances are being used, regardless of what else is happening. So essentially, this means that they're shared. These singleton services are shared by all your DB context instances. That can be significantly more efficient than creating a scope service every time, but it means that they have to be thread safe because you could have multiple context instances being used by multiple threads calling into these services. And in fact, a lot of them are stateless, and so they're just thread safe by the fact of being stateless. And also, it means that they can't change based on different context configuration. So you can't, for example, say, oh, I want the model validator to validate in this way for this context instance and in that way for that context instance, because there's only one service. And so that kind of has a limitation on what you can do there. And later on, if we get time, I'll go into building the internal service provider and the consequences of using singleton or scoped instances for that, and when we have to build a new one. Shall I?
So yeah, there's as Arthur said, basically the idea here is whether the thing is per context or not, or global. That's kind of
Yes.
like the distinction that we're
Yes.
talking about. And that's
Yes.
important. So the thing is if you scroll down a little bit to look at the scoped services, then basically every time you're newing up a context, you're also newing up everything here that says scoped. That is basically what it means.
Well, you're not quite, right? So this actually, there was a question there. Right, this here, right?
Right. In terms of lazy or not, yeah. Good point.
Yeah. So let's talk about that. This goes back to, I guess, the kind of the way DI works, right? So let's say let's use a simple one, let's use the navigation fixture, because that's relatively straightforward. So if you look in, so all our services are defined by interfaces. There's one exception to that I'll get to at some point, but basically that's a rule that we have. If it's a service, it's defined by an interface. If we have to break the interface, we deal with that. It's a lot easier now with default implementations and stuff, but we want it to be clean for that. So all of our internal services are defined by interfaces. We also, just while I'm here, we've tried to document each of these because it is useful for extensibility. So even though this is internal, we still have this bit of documentation here about the service scope, just so that if you're messing with the internal services, which is fine, as long as you're okay with us breaking you when we change things, then at least you have this bit of information so you can understand that. So I'm going to go to the implementation of this, and you'll notice that we do have multiple implementations here, but almost all of them are just for testing things. And I'm not going to go into detail in this now, but actually it's really useful having the service-oriented architecture when you're testing things, because you can easily inject fake instances, testables, essentially, when you're testing other components. And so you can see here that we've got a test navigation listener in one of the tests, which is adding some additional things so we can see what's happening. So that's one of the advantages. But there's only really one implementation of the actual navigation fixture, which is called navigation fixture. Now, it has dependencies. So we use all constructor injection. There's no property injection here. So all of the dependencies that are needed by the navigation fixture are defined by constructor parameters. And in this case, there's one dependency, which is the entity graph attacher, which is itself a service, right? So what does this mean in terms of when you instantiate a thing, whether it's done lazily or not? Well, what it means is that when you request a service, so let's say the state manager says, I need to do navigation fix-up, and it requests a service for that, then which of the other services are instantiated at the same time depends on the dependencies of these things. So in this case, navigation fixer will say, okay, I depend on entity graph attacher, so the DI system is going to go and find the implementation of that. And I think we'll find, again, other than test, there's only one of those right now. And it says, okay, I'm going to inject that for you, and this in itself depends on the entity graph iterator, which again, there's one of those. And it doesn't have a constructor, right? So it's basically, this doesn't have any dependency. So that's where it stops. So if you say, give me a navigation fixture, you're going to get the navigation fixture, you're going to get the entity graph attacher, and you're going to get the entity graph initiator or iterator, sorry. So that's the level of that you get when you ask for things. So in reality, then, the stuff that you get when you create a DB context instance depends on what services DB context requests and what all of the dependencies are for those. And in reality, it's not that complete list of things, but it is a substantial part of those things. And we have done work in the past to kind of decouple some things and make it so that it requests fewer services eagerly when you create a DB context instance. We don't have as much of that right now, partly because we also have the context pooling. So you can actually, because you can use a context pooling, it doesn't matter so much whether when you initially create that DB context instance, it eagerly creates a load of services, because you then pool it and you don't have to do it again each time. Shai?
Yeah, it's been an interesting development. So I think originally we had less scoped services and more singleton services, and that's good because again, it's fast. You only instantiate the singleton services once, and then you share them around all the DB context instances. But gradually, for various functional requirements, we needed to do features. We had to add more scoped services, and also convert some singleton ones into scoped ones. That kind of happened over time. And every time you do that, basically, you're adding more, you're adding more work to the act of creating a new DB context. And we usually tell people, don't worry about it. You can instantiate as many DB contexts as you want, and that's correct. It's not heavy. Like at the end of the day, you take a DB context, you use it to communicate with the database, the network to the database, and the I/O the database is going to do. That's going to be the significant part. But for very high perf kind of applications, we started seeing that that thing starts to show up a little bit, right? If you're really looking at benchmarks and hyper scenarios. So because of that, as Arthur just said, there's the whole DB context pooling feature, which basically means we're going to instantiate a DB context once, and then we're going to pool it. We're going to reuse it all the time, so with that we don't have to rebuild the scoped services every single time again and again. So that's a way to sidestep this whole problem. And because of this, we don't care that much anymore about adding scoped services. Not as much as before in any case. I hope this connection between the DI thing and the perf is clear to people. It's actually quite important.
Yeah.
So question for you, what do you lose excuse me, by pooling? In other words, why would that not be a default is a question I'm sure comes up.
We discussed this a lot. It's even a little bit controversial, I think, in the team. So I'm the perf guy, and I push for pool by default in general. The only problem with pooling is that if you have any sort of state on your context, like a user ID because you're doing multi-tenant, then things become tricky. It's not that they become impossible. There are ways to do it, but it becomes more complicated to work around it. So the moment you have state on your context, basically pooling becomes difficult, because pooling something with state is difficult. We even added some documentation on how to do multi-tenancy with context pooling recently to go around these problems. But basically, my advice, I think we agree to this on the team, is if your application can do context pooling and you're even a little bit perf sensitive, turn it on. As long as it works and you don't have any state there, it's just going to work and it's going to speed up your application. If you don't, if it's like complicated and you need to do jump through hoops in order to make it work, make a decision. If you want to jump through those hoops, do it. If not, it's fine. It's not necessarily going to matter so much. That's basically the answer.
So actually, that ties very nicely into the tension between the scoped and singleton services, and why we have in fact made a lot of services scoped. And that I alluded to it earlier when I said, well, if you want to change the configuration in a service per context instance, then it needs to be scoped, because obviously if it's singleton, all the context instances are using the same service, and so it has to have the same configuration. And one example of that is logging. So at one point in the history of EF Core, logging was a singleton thing. So every context instance used the same logging configuration, which seems somewhat reasonable. Which is why we did it. But in fact, what people want to do is they want to do things like use Logger Factory on their context instance, and then they want to use a different Logger Factory in a different instance, or they want to do log2, for example, and they want to log to a different place on one instance and they're doing on another instance, or they want to switch on different events or configure that differently. And so essentially what we ended up doing was making logging scoped, so that basically your logging configuration is now tied with your context instance, and so different context instance can log differently, which is great, and it adds that flexibility. But it means that anything that wants to log has to either itself be a scope service, because it also is going to has to use that scope service that inherits the logging information, or you have to now like pass the logging context information to a method on the service rather than it being a dependency for the service. So that's kind of an example of the tension there. And you could that same thing actually ties into the whole pooling thing. So one of the things that that's actually came up recently on GitHub is that you can't override on configuring when using pooling and change the configuration each time you create a new context instance. So you can't say log to this one in this instance and then in another instance log to the other one for the same reason, right? Because now you're using the same pooled instance. It's essentially state that we're maintaining, and we don't want you to try and change all of that state every instance. It's quite difficult. The context does contain some state that changes every instance, and we explicitly what the pooling mechanism does, it resets some of that state. But then that's kind of like a balance between how much state do we allow you to reset and how much state is tied to the actual context instance. And the trade-off there is, like Shai says, if you can use pooling and your application, then use it. If your application's super high perf, then definitely try and use it. But at the same time, you have some limitations in there. And if you want the full flexibility of doing all of these things, another one is injecting different services into your DB context itself based on, so you need to have a new instance created, because otherwise there's nothing to inject the new service into. So you want those things, then don't use pooling and don't think that that's going to kill your perf completely. It's not. So let me also say, connection pooling is not context pooling.
Yeah.
Turning off connection pooling is really, really bad for performance, because connection objects are really heavyweight, like the native connection objects. Turning off context pooling is not that bad. It's perfectly fine to do most of the time.
Yeah.
So don't be afraid
it's an
of
order
turning
of magnitude
it off. But
difference.
yes.
Yeah.
Okay. So coming back to this, what we looked at, I think, was the add core services, right? So I'm going to talk about this a little bit more. And in fact, one of the places, I wonder if I can find usages of this, just so we can find where we actually call try add core services. And it's going through here. I want to find the let's see, EF core in memory. Where's it? Here we go. So here. So the reason I was looking for in memory is because typically database providers are the things that call use or what was it called? Try add core services. You can see it down here. So this is a extension method that most people don't normally call. If you are calling this, you're probably doing it wrong. You might not be, but you probably are. Which is, in the early versions, like in EF Core 1, you would call a method like this, and that was a normal thing to do. But these days, you don't call it. But nevertheless, this is what sets the internal service provider up for a certain database provider. So in this case, we're looking at the in-memory database. And you can see it does a few things here. The first thing it does is it creates its own entity framework services builder based on the service collection, which is what you get out of DI to build your services before you create your DI container. And it adds using the same triad method, a bunch of customized services. Because it's using this triad method, remember that means that it's going to get the scope correct, and it's going to get the whether or not it's a multiple registration correct. So this is one of the main reasons we had it. So provider writers can just do triad, and they're not adding a singleton when it's supposed to be a scoped, or adding a scoped when it's supposed to be a singleton. Although provider writers don't always necessarily know this, right, Shai? And so sometimes they do the wrong thing here. But if they're doing it right, then and this is why maybe we should do a community center where we write a provider from scratch. But anyway, that's a whole different kettle of fish. Go, Shai.
I'm wondering, could we look at like a provider that's not in memory? Because I hated the in-memory provider. Yeah, very cool. Very cool. Okay. I'm just
right.
Very cool.
So let's look at some of our favorite services here. So iModel Validator is the one that I'm going to keep coming back to. You'll notice here that there's an in-memory model validator. So if we go look at that, we'll find it actually derives from the base model validator. So we wouldn't have to do this. If we go back to the base service builder, we'll see if we find model validator there. I can't see it, but I know it's there somewhere. Maybe I should just find
up
it.
There. It's right there.
There it is. Okay, you can see here that by default we just add the basic model validator. So if you don't do anything, if your provider doesn't need any custom validation of the model, then we've got you covered. We've got the basic model validator that does all of the normal model validation. But quite often providers will want to add their own validation into there. I can't remember exactly what the in-memory validator does, but we can take a quick look and see what it does. Oh yeah, it validates that you're not using defining query incorrectly. So we've got this additional basically validation in the model there, which checks that you have I don't remember, some combination of things that you're not supposed to do. So what we're doing in terms of the services here is we're saying when we create the services builder, the first thing we're doing is we're adding an in-memory model validator, and we're doing a triad, right? And a triad means only add this service if some other service that implements iModel Validator is not already added. When we talk about multiple, it's slightly different for that, but for single services, that's what it means. So then at the bottom here, we call triad core services, which is where we were looking before. And this gets to there and it says, oh, already have an iModel Validator, so I'm not actually going to add this. So the consequence of all this is that when you use the in-memory provider, it's overridden the service for iModel Validator with one that's specific for the in-memory database. And that's basically kind of how the integration in this service-oriented architecture works for providers. It allows providers to override services that they need, replace them with their own implementation, and indeed, in many cases, actually derive that implementation from our base class implementation, so you're not having to rewrite everything, you're just having to do certain bits of it, right? So that's kind of fundamental to the way that integration works. And in fact, it actually is similar for plugins as well. Plugins will do a similar thing in that they also can add methods that will override services to change the behavior of certain services in the service provider that we build. Okay.
I think, by the way, this is a really, I remember when I started on the team and I knew about DI, but I think this really drove home for me the idea how DI enables you to kind of like pick and choose and replace things in this whole bundle of services which work together. And the provider, yes. Like this screen is, by the way, a nice example. In memory doesn't replace so many providers.
Right.
It actually replaces quite few, which is, I'm guessing, why you wanted to show it. That's actually a good example for that. But it's really nice. It customizes exactly those little things that it needs to customize. Like in a relational provider and a SQL provider, for example, if you need to customize the SQL, then you're going to override the query SQL generator, which is the service that's responsible for actually rendering SQL. So you're going to have your specific thing for the SQL dialect of your specific database, which you're implementing. It's really, really nice. And all the rest you don't even have to concern yourself with. So it's really elegant in how it works and allows providers to basically tweak everything, but not have to deal with anything.
So is
go ahead.
Oh, go ahead.
Go ahead, Jeremy.
I was going to say, is the concept here that if you're running in an ASP.NET Core application that wires up its own service collection that gets handed off and it plugs into that, versus if you're in a standalone console, it's creating its own service collection, or how does that handoff work? Because I know there's people trying to use dependency injection in console and desktop apps, for example.
In a word, no.
Okay.
It used to be like that. That was kind of the idea when we very first started doing this. We started on this implementation. The ASP.NET or just modern .NET applications, of which ASP.NET Core was kind of like the first example, would have an application service provider, and then EF would add services to that application service provider and implement them in various ways, and it would all just be one big happy service provider.
Sure.
In reality, that doesn't work very well. And the reason is that the two things can interfere with each other. So, for example, the EF is adding all of these services that your application doesn't care about, right? Which is not terrible, although perhaps not ideal. But it's also doing things like, I'm going to see if there's iLogger factory here. Can't remember exactly whether so here you see we actually register a service for iLogger factory, but your application service provider may also have a service for iLogger factory that you've implemented or defined to do what you want it to do. And then if we try and use yours, it won't work for what we want, and if you try and use ours, it won't work for what you want. And so you get into this state where you've got this coupling between the two that you don't really want. So what we did is we essentially made the default be that EF has its own internal service provider, and I'll show a little bit later, hopefully if we have time, how that actually gets built, and it's separate from your application service provider. So essentially your application service provider, the ASP.NET Core has its own set of services, and that's in fact what DB context gets registered into. That's when you call that DB context, you're actually changing the application service provider. But internal, when you create a DB context instance, it's using this internal service provider, which has a separate set of services. Now, there is a thing where you can call use internal service provider, where you can combine the two together in the kind of more old-fashioned way and manage all that yourselves, and that can be useful in some corner cases, but it's not what we recommend. We recommend that the two things be created separately.
Can you give an example when it's useful? I'm curious. I don't know the answer to that.
Essentially, yeah, that's a good question. Now I'm going to have to wrap my mind. So I suppose it's not a question of when it's useful for there to be, a single service provider, but sometimes you might want to manage the internal service provider yourself, because we do basically a simple app domain cache of service providers that we can look at. And you may actually want to cache service providers differently, or you may want to be able to evict them in a way that we don't do. And so if you're actually creating a lot of different contexts with a lot of different options that require a lot of different service providers, then having full control of that can be useful.
So it's more about
yeah. Go ahead.
So it's more about like providing a blank service provider which you've customized, then sharing necessarily your application service provider with the EF.
Yeah, it's really allowing people kind of in the what we've talked about before in some of these sessions, the escape hatch. Like, we're going to create an app domain cache of service providers, but hey, if you want to take control of that and do something different, this is how you do it. So a concrete place where problem that we had with EF6, for example, was it wasn't possible to do that. And a lot of things were just cached at the app domain level. And then we had people saying, I need to be able to evict things from that cache, and we didn't have a way to do that. So this essentially allows you to do that. So if you, in certain scenarios, you may need to, have control of that cache of service providers and evict things, and this allows you to do that. But for most people, the number of service providers in that cache is one or a small number, and you will not need to do that, and you just use the default.
So conceptually, for me, then I would think of it as the DB context is the boundary. So I've got my service collection here. You've got your internal one. You give me an extension method so that I can register the DB context. You're going to hand it to me with all the internal services. and then we have the configuration to tweak
Yes.
those
Absolutely.
as a
That's
safe
correct.
user, if so
Yes.
to speak. And this stuff comes into play more if I'm like writing my own provider.
Yes,
Is when I would be
absolutely.
getting into some of the
This
internal.
is the internals. This is not stuff that you normally need to think about as as a user, an application writer using EF Core. But as is with this session, the idea is we're actually getting into the internals of how EF Core itself works. And if you're writing a provider, this is the kind of stuff that you need to know about in order to write a provider.
Cool.
Okay, so before I did a probably still there. I looked for usage of before we get to that, I missed something here that I was going to talk about. Providers can also define their own services, add their own services provider that are nothing to do with anything that the core EF provider knows about. So for example, these services are, because the in-memory provider is very simple, these are basically the services that form the functionality of the in-memory provider. And so, for example, if you look at usages of this, we'll see that in the internal implementation of the in-memory database, it depends on its own service, which is the in-memory store cache. So this is basically just how the provider can add its own services, depend on those in the DI way without it being controlled by, they're not part of the common services that get replaced or whatever. So now let me go back to what I was going to do, which is uses of Triad Core services. So let's look at, we've looked at a non-relational provider, as Shai said, the in-memory provider, but now let's look at SQL Server, which is a relational provider. And as Shai said, you can see that it replaces a lot more services, but this isn't the only story, right? Because there's actually this thing called the Entity Framework Relational Services Builder. And this comes in because you may or may not know there's a layer between the core entity framework implementation and relational providers like SQL Server, SQLite, Postgres. And that's this relational layer where we provide a lot of common implementations that are not general to all EF. So they're not necessarily, for example, the Cosmos provider or the in-memory provider wouldn't make use of them. But any provider that essentially uses the ADO.NET abstraction, the system data stuff underneath, these provide a common usage for an implementation of services around that thing. And the Entity Framework Relational Service Provider lives there, and it essentially it extends the Entity Framework Services Builder that we saw before, and it has a bunch of relational services, just like the core services, right? But these are defined with service characteristics, singleton or scoped, multiple or not, for example, and they define a bunch of things that are common to relational providers. And so now, if we go back to where we were there, you can see that because this is now adding things to the relational, it's using the relational service provider, when it calls this Triad Core Services down here, this is actually, we're not getting the right one because it's overridden in the relational services builder. So what this does now is it adds relational implementations of these services, okay? So let's go through what happens with the iModel Validator, our favorite service again. So let's go look in the SQL, where we were in the SQL service thing. So we look here, and so iModel Validator, here it is. So as with the in-memory provider, we're adding a SQL Server model validator, right? So this is specific to SQL Server. It actually overrides relational model validator, which adds validation that's common to all relational providers, right? If in the SQL Server, we go back again, if in the SQL Server provider we didn't do this, so if SQL Server didn't need any custom validation, but it's still a relational provider, so it still wants to do all the relational validation, then what would happen is when we went into the Triad Core Services in the relational builder, we can see the model validator adds the relational model validator. So what this means is that now when at the bottom of here, we're going to call base triad core service is when we get into this, if we're using a relational provider, we've already got the relational model validator added, so we won't add the default one, we'll add the relational one. Of course, in our SQL Server case, we don't actually add the relational one either, because with SQL Server said I want to use the SQL Server specific one. So we've got this kind of 3 levels, and what this means is, so as Shai had pointed out, when we go to SQL Server, there's a lot of different, there's a lot more services implemented here than there are in the in-memory. But that's not the whole picture, right? Because actually, it's all of these that are in the relational provider that are added that are all different. And in fact, SQL Server is overriding only the relational things that it needs to be specific for SQL Server, and then relational is overriding all the things that it needs to be specific to relational. And so you've got this kind of hierarchy of services being replaced at different levels, so that if you're writing a relational provider, you take advantage of all these things and only customize the things that you really need to for SQL Server.
Yeah, like an interesting point about this. So like Arthur said, we have this whole relational layer, and by the way, it's even a separate NuGet package. So it's really there's like this very, very clear wall inside the EF Core code base between what is core and what is relational. And we frequently have these discussions. Okay, we have this idea for a nice feature. Are we going to put this in core or just in relational? And it's not always clear, where that line should be. Transactions, for example, like transactions. To me, sounds like it should be in relational, like by default, but we actually put it in core because there may be also non-relational databases which support this kind of, concept, and we didn't want to, create problems there. So it's even a separate NuGet package. If you actually look at the NuGet references for the SQL Server provider, you'll see that it references something called Microsoft Entity Framework Core Relational, which is the relational implementation of, of EF Core. And the interesting additional thing about this, obviously, EF Core comes already with a lot of implementation for relational providers. So in theory, if you're developing a relational provider, you have it easy, relatively speaking. Why? Because we already generate, if you look below somewhere, you'll find the query SQL generator. So the thing that is responsible for generating SQL for queries, right? So that thing is already there for you in the relational layer, and a provider will just use that by default. Now, usually a provider is going to have to tweak it because, as I said before, the dialects are a little bit different between databases. So there's going to be a bit of stuff to tweak, but you already have the entire SQL, like basic SQL generation done for you by EF Core. On the other hand, if you're doing a non-relational provider, we don't know what a non-relational provider is. It could be anything. It could be, Cosmos. It could be in memory. There's a completely open array of what a non-relational provider is. So typically, if you're writing a non-relational provider, we've not implemented that much for you as we have in relational. So it's kind of interesting. Sorry, go ahead, Jeremy.
So a nuanced question. If I'm implementing a provider for a relational database that does not speak a SQL dialect.
So when we say relational in our world, what we mean is that it speaks SQL. And there's a good reason for this. So
it's more than that.
It's more than that, yes.
What we really mean, when we say relational, what we really mean is it uses the ADO.NET abstraction. So it uses system data, it uses DB connection, DB command, those things.
Right.
It was pointed out by a user very, very, correctly that there are relational databases that don't use the ADO.NET connections, and they would not work with the relational provider. And
that's right.
Likewise, Cosmos provider actually uses SQL, but it's not a relational provider, right? Because it's not relational, and it also doesn't use the ADO.NET abstraction. So we say relational as basically shortcut for it's based on ADO.NET.
But it's also worth saying, so ADO.NET itself presupposes SQL. So there's no such a thing as ADO.NET without SQL. The whole idea of ADO.NET is you send SQL commands to the database. It's a string of SQL. It might not be SQL. It might be just a string, but basically it's just SQL. So relational means ADO.NET, which means SQL. So these things are bound together. But here's an interesting thing. We do have a non-relational provider called Cosmos, which happens to use SQL as well. It's kind of weird. So Cosmos has various ways of talking to it. It has various APIs. It's a cloud database. You can talk to it using the Mongo API. I don't remember the whole thing, but one of the options is to talk to it via SQL, and that's the one we chose for various reasons. It doesn't really matter. However, what it does not have is an ADO.NET provider, and it works in a completely different way. So that's a non-relational provider, absolutely, but that does happen to support SQL, and that's what we use to talk to it. It's really interesting to think about these things.
Indeed. So as an example of that, I'm actually going to look at relational connection and SQL Server connection. So SQL Server connection is the thing that manages a connection to the database at the EF level. And there's not much code in here, right? There's basically some code that allows you to do things with master connections that's specific to SQL Server. There's some multiple actable result sets, but essentially most of the code for this, which is true of all relational providers that I'm aware of, SQLite and Postgres, is in this base class that's implemented in the relational layer. And this is where there's a whole load of stuff here that's about opening connections, creating commands, executing queries. This has a lot of code. So this is a good example of how you use the relational connection. Most of it's done for you, but then you can do some specific things that are specific for SQL Server in your own implementation of that. Okay, so I'm going to now, there's two more things I want to cover before we end this, and we're going to do more of these sessions. So, we'll go into more details of different things, but I want to talk about how that internal service provider is created. So let me see which was the class I want, service provider cache. Go to service provider cache, back, okay. So you remember I said that by default we have a simple app domain level cache of internal service providers, and that's what this is. And it indeed has a static instance of service provider cache. This is a traditional singleton, right? This is old school global singleton, which, as I said before, you maybe don't want. You maybe want more control over that, which is why we allow you to do internal service provider. But if you're not doing internal service provider, then the service provider cache is what handles these things, and it has this method, inline function or whatever this is called build service provider, that is basically doing the work to build your service provider. And essentially what it's doing here is, I'm skipping through some of this, which is about creating debug information. We create a service collection. That's the normal DI thing, right, that you do before you start building services. And then we're going to call apply services, which is down here. And what apply services does is it goes through all of the DB context options extensions that you've added. And I'm not going to go into this in detail. We'll do that in another session. But basically, when you say use SQL Server, for example, what that does is it adds to your DB context a options extension for SQL Server. Maybe I can just look at that really quickly to show you at least the ones that exist. So you can see we've got a lot of options extensions. There's an in-memory one, there's a SQL Server one, there's a relational one, which is like a base class for all relational extensions, there's a Cosmos one. There's also, these are also there for things, plugins like proxy, so there's a proxies options extensions, and the spatial ones have for spatial, and then there's test ones as well. But the main thing about this is each of these extensions has an apply services method. So what you're going to do is you're going to go through these and you're going to apply the services. And if we go and look at an implementation of one of those for SQL Server, where's the SQL Server options extensions? Right here. So SQL Server options extensions, it calls this method that we just looked at, right? So basically, when you've done use SQL Server and we need to build the service provider, it's going to add all of the provider services to that by calling add entity framework SQL Server. So going back to here, we also know basically that you can only use one provider at a time. You can't use SQL Server and use in-memory database on the same context. So we set flags saying, yeah, we've added the core service. If we don't, we add the core service without a provider, which is useful for design time tooling, some scenarios, but most of the time you don't need to worry about that. But basically what we've done now to our service, we've got a service collection that's got all of those services that we just looked at configured. We've got the right ones for SQL Server, otherwise we've got relational, otherwise we've got the core implementations. And then if proxies, for example, let's go look at proxies as an example, just so we can see what it's doing. So if you're using proxies, for example, it's also got an apply services, find that. By services, which is again same pattern, identity framework proxies, and what it's doing is it's overriding a convention set plugin, so that it adds model building conventions for proxies, and it's adding its own service that it uses internally for proxy factories. So this is basically the same thing as a provider, but as a plugin. Okay, so coming back to here, right? So we've now we've done the apply services. Let me go back to the build service provider here. So we've gone through and applied all the services. We then do some stuff here you people may be aware of. I'm not going to go into detail, but there's this replace service function that you can do when you're doing a DB context options builder. So in on configuring or add DB context, you can say replace service. So I could say, I've got my own navigation fixer. I've implemented this because I don't like the way yours works, or I wanted to fix a bug and you haven't released it yet. And so I've implemented my own instance of that. And it might be an internal thing, and that's fine, as long as, like I said before, you're willing for us to break you when we release a new version. But this essentially allows you to then go through and look at those services, pull out what the provider added or what EF added, put your own thing in there and have your own implementation of that service. So that's kind of an application patching, extensibility, kind of let me change the services, let me add my own stuff there. And then we basically just say, okay, let's, we've got to the end of this, let's see where I want to find here. Okay, so we have this concept of creating the provider scope. I don't think that's relevant. So when we come back to the top here, let me find uses of this. That's the easiest way to do that. Find usage. Okay, so up here. So basically what we've said is that's if you don't have caching enabled, but if you've got caching enabled, then we're basically going to say with some cache key, which I'll come to in a minute, either get from our concurrent dictionary an already built service provider or build a new service provider. And this service itself, let me find usage of this, is used in DB context. Okay. So this is kind of tying it together to now how this works when you add a DB context instance. We might want the other use of it, actually. There's a big comment over there. Let's get a hang on.
We're in the plumbing now.
We're in the plumbing. Yeah, this is the bit I haven't prepared very well. Let me go back to my find. Here we go.
Deep down below.
This is the one that I wanted. Okay. So DB context has this concept of its context services. These are the services that we were talking about earlier, that when you create a DB context, these are the services it creates instances of and uses for that. So it doesn't happen, context services doesn't happen when you do a new DB context. Doing a new DB context is very fast. It happens the first time you do something with that context. Tracking an entity, executing a query, calling database ensure created, one of those things. Then it'll lazily initialize this thing. And yeah, if it's not already created, then it says, right, we're gonna go down here and we're gonna get the service provider from this. And in fact, we're actually going to then create a service scope. And this is the scope that we talked about for the context instance. And we're going to set that as our kind of service provider that we use. And then we're going to get this thing called IDB context services, which wraps the excuse me, the set of services that DB context uses. And we do some initialization on that. And that's basically then the thing that gets used to do everything. So we can look for usage of this. We'll find there's a lot, well, there's not a lot of them. I thought there would be a lot of them. We get the model from it. Oh, it's because we have a little helper for internal service provider. We find usage of that. We see that if we need the change tracker, then we get the change tracker out of it, and so on and so forth. So this is kind of the entry point into all of that DI stuff. And this happens regardless of whether you've just called the DB context constructor, you just use new to new up a DB context, or whether you've actually injected it with some options. Regardless of whether you're using DI at your application level or you're just newing it up, you still get this DB context that still is going to create an implementation of that internal service provider and use that. Now, the cache key for the service provider is basically anything that requires different singleton services. And I'm not going to go into the details of how that works, but if you say, okay, I'm going to change there's certain settings that if you change, we will actually need to build a new internal service provider because we need new singleton services. So for one of those, for example, is if you change enable sensitive data logging. So we look at, now I hope everybody knows about enable sensitive data logging. If not, you should do. So enable sensitive data logging, what this does is basically says when I'm logging stuff out of EF, out of queries, out of updates and things, include the parameter values in that. So if I'm going to insert something in a database, which might be a social security number, then I want to see what the number is that I'm inserting, right? It might not be a social security number. It might just be something completely innocuous, but we don't know that. So by default, we don't include that in logging. You turn on enable sensitive data logging, then we will now start including that. And this is one of the things we call a singleton option, because actual singleton service depend their behavior on whether sensitive data logging is enabled. So if you do use sensitive data logging, it's actually going to cause us to need to rebuild the service provider. And I think we should be able to see here. So here, this is where we're actually building that server provider hash code, right? So it's saying all of these things that if you change any of these things, and there's other stuff around, like, the hash code in other places, but the hash code kind of demonstrates it. If you change any of these things, internally, we're going to need to build a new internal service provider. That's not terrible in the sense that I can be using sensitive data logging in one place and not with another, and I'll have two service providers in the cache. That's not terrible, right? That's okay. It's not bad. If you do something like configure warnings differently, and you do it different every time, then you end up building multiple instances in that internal service provider cache, and that can impact your perf, because essentially you're causing us to cache a lot more than we want. You're not reusing things as much as you can. And I think we have a limit in there where by default, if you get to 20 internal service providers, we just throw an exception saying, hey, you're doing something wrong. You might want to go check your code. It's a warning that we treat as an error. You can actually reconfigure it to just be a warning or to ignore it. So if you do want to build loads of internal service providers, you can still do that, but we try and kind of prevent, save you from yourselves. But this kind of goes back to the tension between, singleton service and scope services. Like, we could make everything that depended on sensitive data logging a scope service, but then lots of things, especially in the query pipeline and in the update pipeline, would end up being scoped when they don't need to be for something that usually you have a single value that you set for it. Like, you're debugging your application, you're in a development build, whatever, it's always on, or you're in a production build, it's always off. It's not something that we expect people to change. So there's kind of a heuristic there. So I think that's most of what I wanted to cover. I was going to go into dependency objects, which is kind of interesting if people want to. But are there questions that have come up that we should answer, or have you been taking care of all that already?
I don't think there's anything. Yeah, I've been taking care of it.
I hope people have been following a little bit, and I didn't just lose everybody in the details there. But yeah, let us know if this is useful and you want more of these, where we go into further parts of how EF works, the DB context life cycle, and the model building conventions. There's a lot of things that we could cover in one of these sessions. If there aren't any questions, then I will just go quickly talk about dependency objects because they're interesting.
There's a question about do providers implement migration services, which might be a good excuse to mention the idea of design time, briefly.
Providers can implement migration services. So we do have this concept of design time services, which are services that are used at design time, but are not used when you have a runtime application. And so these are typically provided by the design package. Now, a lot of services used at design time are also runtime services. And although you might not think of it this way, if you look in the relational service builder and we search for migration, so these are all runtime services, but there's actually quite a lot of migration services that are relational. I say that and then I only find two. I think, but if you look at the definitions here, we've got, for example, the iMigrator, the migration model differ. These are actually runtime services because when you do data, you do ensure created or you do call migrate, which is available at runtime. It uses these things, but then there are also things that let's see. Can we find design time services?
Migration SQL generator, by the way, is an important one for providers. That's where a provider customizes all the SQL it uses to do migrations. Basically, how do you create a table in SQL Server as opposed to Postgres? This is where that happens. Create a table, change a column's type, add an index, drop an index. All that stuff has to happen in the migration SQL generator.
Yeah, we really need Bryce to find where the design time services are. Maybe this is a good place to see some of them. Oh yeah, so these are a good example. So we have this relational design time services builder and then SQL Server design time service, which is replacing these. So things like the code generator, like we don't generate C# code at runtime ever, right? We generate C# code when you're scaffolding or when you're doing your scaffolding migrations or when you're doing reverse engineering. But you don't need to do that at runtime. And so these are separated out into design time services, which are only used when you're at design time. And so when you build a service provider for use at design time, it has these services. It also, as I said before, includes other services that are just normal runtime services. So you can see here we've got Triad Core Services at the end, so it's including all the runtime services as well. But it can replace certain things with it can replace core service if necessary, or add its own design time services in there. There's a discovery mechanism that's used by toolings that's going to be able to find the design time services when you use a certain tool and all that stuff. But that's quite complicated, and I always get a bit scared if I have to go into that code. So let's say no more about that right now.
When Arthur's scared to go into a piece of code, you're
that's not true.
You're in a bad place.
Query pipeline, I'm always scared.
Yeah. But everybody's scared. Possibly even Smith, who was the architect.
Yeah. Let me look at this again. So we have these things called dependency objects. I mean, dependency objects is a general term, but let me see if I need an example of one that actually has something in it. Relational connection dependencies, does that have stuff in it? Yes. Okay. So I'm going to look for usage of this. Now, you remember when we looked at the implementation of navigation fixture, and I showed you that in its constructor, it depended on the services that it needed, and then, so on and so forth down the chain. That's the normal way that DA works and the simple way that DA works. But what we found was there was a problem with that when you had providers providing their own implementations of service. So remember, we looked at relational connection before. So relational connection is overridden by, for example, the SQL Server and SQLite, and Postgres probably overrides it, okay? Now, if in the SQL Server connection, we had a constructor that took all those services and we passed that down to the base of relational connection, so this took all those services as well, that's fine when you write it. But let's say we want a new dependency on relational connection, which happens, right? We then add a new dependency, a new member, a new parameter to this constructor. And now all the providers that have overridden relational connection, so the SQL Server connection, they're all broken because they don't see that service. And not only are they broken, but if we added a new overload of the constructor, they wouldn't be broken, but they'd be calling the wrong one because they wouldn't get that service injected. And so, in a way to solve this problem, we created these dependency objects. So what the dependency objects is, they collect together all of the services used by, for example, relational connection, right? And so these are all of the services that you would normally just put in the relational connection constructor and be constructor injected, but instead they're connected, they're injected into the dependency objects. And there's a big warning here. Basically, don't call this directly. Don't use this, right? You're only ever supposed to resolve this from DI. And that means that if we go back to SQL Server connection, it can depend on relational connection dependencies, which we can now freely add new dependencies to without breaking SQL Server connection. So we've kind of added this additional layer of abstraction around that, so that basically we can use DI and we can have people inherit from our base implementations of those services without then breaking them every time we need to change the dependencies on that implementation.
One comment I wanted to add to that. So this is especially important since maybe we're going to add a service there that SQL Server connection doesn't actually care about or want to take a dependency on, right? That's actually the thing here, right? So we sometimes in our base classes and relational connection, we need to add dependencies. Sometimes we need to remove them, and implementations should not even care about this. That's basically the point here, right? So this object, this wrapping around all these dependencies is a way for us to slip in stuff and remove it and do whatever we want. That's our package. The provider isn't supposed to care about it. And that's it. And it makes everything, it prevents a breaking change basically every time we release something and we want to change a dependency, which is quite cool. And I've actually seen this. This is not necessarily only a DI pattern in general. When you have,
it's not.
Like a base class abstraction and you expect people to inherit from you, sometimes you want to wrap your connections, especially when there's many of them and they're going to change. You want to wrap them in some sort of like wrapper object like this so that you can modify it without breaking the implementations of that base class. That's something maybe to take away. It's a pattern.
And this is when I said there was one exception to defining services by interfaces. This is the exception. These things are sealed records. You never extend from them. You never create another implementation. So there's no point in it. In fact, it would be detrimental to have an interface here. And one of the really cool things that happened actually is that these are sealed records. They weren't originally sealed records because sealed records didn't exist when these were written. They were immutable classes that had constructors and then patterns that used with X with property in order to create a different copy of them. When records were introduced, it matched exactly what we already had implemented in these dependency objects. And we ripped out all that code without breaking anything and just called them records. And it just worked. And it was like, wow, you've implemented exactly the pattern that we already had for these immutable
That was one
classes
of
with
that was one of the
initializers.
most fun PRs. I think I did that PR,
I
and
know.
that was one
It's
of the
so
most
cool.
fun PRs in the world
Yeah,
because you
it's
you
like-
chop all that code and you don't need it anymore.
And the
It just
compiler's
works.
just doing it all for you. And I'm sure it wasn't planned. I'm absolutely sure that the C# design team didn't look at our dependency records, but I guess great minds think alike or something, and they implemented exactly what we already had, which was pretty cool and somewhat a vindication of the pattern in a sense. It's like, oh yeah, this pattern
Absolutely.
that we've come up with is what the compiler's going to do by default. That's pretty cool. So that was all quite nice. Anyway, yeah, so if there's no more questions, I think that's a good overview of the internal dependency injection in DI. I think so. We've lost Jeremy. I guess he had some other commitment to go and do. So yeah, we'll if you like this, then tweet us or let us know somehow or comment on something or whatever, and we'll try and do some more like this. It was fun, and it gets more hairy as we go into more detailed things. So I'm sure it'll get a little bit more scatological, if that's the word. Anyway, anything else, Shai?
Nope, I think we're good.
Okay, then I have to find out how to press the right buttons to actually leave. So let me. I think you're going to No, hang on. Banners? No, I don't know. Bear with us while we end the show here. Okay. Thanks. There's a thing called thanks. So I'm gonna hit that. So thanks everyone, and we'll see you next time.